Okay, so we put in a -1 for x. So x squared plus 1 is -1 squared plus 1. Now what do we do? What's a? Okay. So we're just writing everything that we can here. So this is -1 times the quantity x minus 1, but what did we allow x? X is -1, so this is -1 minus 1 to the third power. Plus b, we don't know b, so it stays as b, but the value we chose for x for this particular one is -1. And we're letting x equal -1 as well. We also don't know c. But we do know d. Where did you go? D. Oh, 2. D is 2. So this is 2 times -1. Wow! Now, let's just... Everybody stop for a second.
Are we going to be able to solve for B or C with this one equation that we have? What do you think? Are we going to be able to find out what B equals?
Well, we have two we need to find. We can accelerate in terms of B.
I want you to understand the direction we need to go. Both of you are right. We could solve for B, but it's going to be in terms of C. We're going to have something like B equals 10C minus 5 or something like that. So do we know the specific value of B? No. So we're going to have to repeat this process again. We're going to have to choose another value for x, and then use A equals -1, B equals 2. Then we're going to get another equation in terms of B and C. Why do we want to have two equations in terms of B and C? What's this whole unit really been about starting in chapter 10? Systems of equations, right? If we have two unknowns that we need to solve for, we can't solve that with just one equation, so we're going to have to make another equation and set up a system of equations. Yeah?
So, couldn't we solve for B in terms of C and then substitute the B in terms of C value to be in for B, and then solve for C, and then use that to solve for B?
Yeah, but you can't plug it back into the same equation that you solved for B. So if we're going to solve this to get an expression in terms of B or C, and you can't plug that back into itself to solve for C. You'd have to have a second equation. Okay, let me tell you what I mean. Let's go ahead and solve this. -1 squared is 1, 1 plus 1 is 2. So left side there gives you 2. That was not so bad. But on the right side, you really got to pay attention to your
arithmetic. It's simple arithmetic, but you got to pay attention to it. So start inside the parentheses first. Inside every single parentheses, what are we going to get?
Every single one of those parentheses, it's the same. Well, the ones that have two terms. -2. So it's going to be -1, and then we're going to have a -2 to the third power, minus b times -2 squared, minus c times -2 minus 2. I would avoid trying to do too many things in your head and trying to combine too many steps at once. That's going to lead to simple mistakes. This first term, -2 to the third power is -8, but -8 times -1 is +8. -2 squared is 4. 4 times -b is minus 4b. We're going to have a plus 2c minus 2. So if we take 2 away from the 6, we're going to have 2 equals 6 minus 4b plus 2c. Subtract the 6 to the other side, you're going to get -4 equals -4b plus 2c. So we have one equation in terms of two variables, b and c. We can't solve for b or c.
So we need one more equation. We need a different equation now in terms of b and c. So how are we going to get a different equation in terms of the same two variables, b and z, or and c?
How are we going to do that? Okay, yeah, I mean we could, but that's just going to be the same equation, just manipulated. Does that make sense? We need a different equation. Where did this equation come from right here that we have?
It came from letting x equal -1 and a and b equal those values. What if we chose another value for x? But then let a and d equal the same thing. Would that give us a different equation? Would it be in terms of b and c? So then we could solve that system of equations. So we got to repeat this whole process with another value
of x. So, anybody have any burning desires for a value of x?
0.
0. We already let x equal 0, though. Did we let x equal 2? Let me see. X equals 0, x equals 1, x equals -1. I have 2 would work. Let x equal 2. Oh man, I forgot. I can't even see it anymore. Where is A? A is -1, and D is 2. So we go through that whole thing again. 2 squared plus 1 equals -1. 2 minus 1 squared, or to the 3rd power. Plus b times 2 times 2 minus 1 squared, plus c times 2 minus 1 plus, what is this last term right here? dx, so that's going to be 2 times 2. Oh, Maddie, there's an empty seat right here or right here. Up here. Nope. Two squared plus 1 is 5. 2 minus 1 is 1 to the 3rd power is 1 times -1 is -1. 2 minus 1 is 1. Squared is 1 times 2b is, so this is -1 plus 2b. 2 minus 1 is 1 times 2 times c is 2c plus 4. -1 combined with 4 is 3, but 3 from 5 is 2, so 2 equals 2b plus 2c. Yeah. We just had to choose a random value for x. We're not solving for x. We're solving for a, b, c, and d. So it doesn't really matter what x is.
But before it was -1, so I can't.
Because if we let x equal -1, we'd have to use the same 2 values for d and a. So we would just end up with the same equation again. We need to get a different equation in terms of b and c. Because now that we have this one here and this one here, now we can form a system of equations and solve it for b and c. Does that make sense? Yeah.
So whatever x is, how does that change what a and b are?
It doesn't. A and b are the same. We let a equal -1 and b equal 2.
Okay. You would find random values for those.
No. Because we solved for a earlier. Where was it? We solved for a. A was -1 and b was 2. They're always going to be there. Okay. But x is the one that we're changing. Because here we let x equal 0, here we let x equal 1, so now we're letting it equal -1, and now we're letting it equal -2 right there. It can be anything. Because we're not solving for x. We're solving for a, b, c, and d, so it doesn't really matter what x is. Well, what do we do with these two now that I've boxed in? Systems of equations, and we can solve this using like 5 different methods now, right? Or you could maybe think about it.
Do we want to use Cramer's rule? Do we want to use matrix algebra? How about low echelon form?
Yes.
You guys are boring.
Hey, I can know how to solve it without even writing anything down.
Without writing anything down?
Here.
I'm going to write it down. Okay, go ahead.
Alright. Notice how the only difference is in B. And there's no difference in C. And it's exactly the same. Here and here.
Okay.
So b equals 1 and c equals 0. You can solve it any way, but that's what you're going to find.
So you're saying the B has to equal 1 and C has to equal 0.
Yes.
All right. I like that reasoning. Let's try it. That's pretty clever reasoning.
Thank you.
Now, if we were to solve this, it sounds like you guys want to use the elimination method because you're just boring. You don't want to try anything different. Or practical. All right, practical. If we are going to solve this using elimination, I would multiply the bottom one by -1. So we would get -4 equals -4b plus 2. See, the bottom equation is -2 equals -2b minus 2c. Oh, looks like you might be right. What did you say? B equals, Kyle?
1.
B equals 1 and C equals 0. Let's see. We're going to get -6 equals -6b. Oh, B equals 1. And it is right. C equals 0. Way to go, Idaho.
How did you know I was born in Metro?
Were you really?
Yeah.
I was just quoting Toy Story. So we have all four. We have A equals 1, D equals 2, C equals 0, and we have B equals 1. So we got to go all the way back to the form of the partial fraction, which was way up here. Okay. We knew that this was what the partial fractions were going to look like. We just didn't know the values of A, B, C, and D. Now we do. So the partial fractions are -1 over x plus 1 over x minus 1. Now, yeah, that's what I was just going to ask. If c is 0, 0 divided by anything
Is what? 0. So if you have one of these that's equal to 0, that term just disappears. We don't need that C term right there.
And then d was 2, so this is 2 over x minus 1 to the third. And those are the partial fractions. Pretty awesome, huh? In time, you will learn to appreciate this as much as I do. Or I guess for that one moment in calculus when you have to use it for one lesson, and that's it, then you will appreciate this. Okay. Oh, we still need to practice a few more because we haven't done one with case 3. Were those sighs of joy? Because they better not have been sighs of, oh no.
No, it was like no.
Were they sighs of shut your mouth and just man up? Was that what they were?
I think they were signs of what's out.
That's what I heard. Okay, example 42.
Wow.
2x squared minus x plus 4 over x to the third plus 4x. Oh, while I'm thinking about it, so I don't forget, let's continue. All right, directions, right? The partial fractions, or find the partial fractions. That involves, first of all, figuring out what case we're in. Is this case 1 where we have distinct linear factors? Do we have repeated linear factors? Or maybe we have an irreducible quadratic factor. Well, what is it? Irreducible? This can factor. This is not irreducible. Okay. So it's not irreducible yet. 2x squared minus x plus 4. So now if you factor out an x, now consider what we have. Do we have
just case 3, or is this a combination of a couple of things? It's case 1 because we have a distinct linear factor here, x. There's only one of them, so it's a distinct linear factor. And then we have, now this is a quadratic factor, but is it irreducible? X squared plus 4. It is irreducible. What if it was x squared minus 4? Then we could use difference squares, but that is irreducible, doesn't factor. So,
we could factor using complex numbers. It would be something, it would be x minus 2i and x plus 2i. But this only deals with real numbers.
And you can't factor
And even if you could, you wouldn't want to. The numerator doesn't matter. So we set up the form of the partial fraction. Since we have a distinct linear factor, this can be a over x. Okay, look through your notes though. Look at it.
go to objective 1. What does the form of the partial fraction look like in case 3? It's much, much different than case 1 or 2.
Good. The numerator is not just one term like b or c. It's a linear expression, bx plus c, over your irreducible quadratic factor. Okay, now we multiply both sides by the lowest common denominator. Which is x times x squared plus 4. We multiply it on both sides. On the left side, all that does is reduce the denominator, so you have the numerator, 2x squared minus x plus 4. On the right side, when you take the LCD and multiply it to the first part of that parenthesis, the x's would cancel, so a multiplies with x squared plus 4. And then when the LCD multiplies that term, the x squared plus 4 term cancels. So the bx plus c multiplies with what? X. Okay, this is going to require some thought. Are there any values of x that would cause an entire piece of that to disappear? 0. Which term are you thinking of then? Which term was going to disappear if x is 0?
Okay. I agree with you there. So if this term disappears, what could we solve for?
Solve for a.
We can solve
the
for
other
a.
second equation would be simplified into 4.
True, true. So what I really want you to think about now and consider, is there anything we can do to cancel that right there? Is there any value of x that would cancel that out? No. Imaginary numbers. No, not any real numbers. So we do have one convenient value of x. X could equal 0. That'll let us solve for a, but that's going to leave b and c. So we'll deal with that when we get to it. Let's let x equal 0. If x equals 0, the left side, what is the left side if x equals 0? 4 equals a times 4. And then we chose 0 specifically because this second term would disappear, so don't worry about this second piece right here. So a has to equal 1. Now, this can be a lot like the last problem. Since there aren't any other nice values of x that cancel an entire piece of this, just choose any value of x, relatively small if you can. So use that value of x that we're going to choose and use this value of a. And then we're going to have to make two different equations in terms of b and c and solve the system of equations. So
what would be a nice number for x? 1 is probably, I was actually thinking of 3.14, but 1 could work. Let x equal 1 and a equal 1. Alright, just be careful with your math. Use your fingers and your toes. On the left side, what do you get on the left?
5.
Let's see, 2 minus 1. Yep, 5. And if A is 1, then this is 1. 1 squared is 4. What does this whole thing turn into here? A is 1 and X is 1. This is easy. Come on, you guys. This right here. This right here turns into 5. Plus B plus C times 1, so I guess we don't really need the parentheses. So B plus C equals 0. Is that sufficient to say for sure what B and C equal?
No. B and C could be negative 1 and 1, or B and C could be negative 2 and 2, or negative 10 and 10. All we know is that they're opposites of each other. Whatever B is, C is the opposite, because the sum of that is 0. So how do we know the specific values of C and B?
We do another equation. We let X equal something different, but we let A equal the same thing, because A does have to equal 1. That's what we solved for. All right, another value of X. If you don't choose one, I'm going to choose 48, and we're going to have to use it.
Negative 1.
Negative 1 or 2. Which one would be better?
Negative 1 would be negative 1.
Negative 1 it is. Let X equal negative 1, and A is still going to equal 1. So, negative 1 squared is 1, 2 is 2, 2 plus 1 is 3, 3 plus 4 is 7. So the left side of that equation is 7. Are those crackers for breakfast?
Yes.
What breakfast is that? Okay. Anyway, let's see. A equals 1. We let X equal negative 1. Negative 1 squared is 1 plus 4. So that term is still 5 right there. So 7 equals 5. Ooh, what happens to that negative 1 there by the parenthesis? Changes it to a plus B, but minus C. So 2 is equal to B minus C. So we take the 2. That we know 0 equals B plus C. 2 equals B minus C. Oh, it's set up so nicely. So if we eliminate here, we get 2 is equal to 2B. So B is equal to 1. So what does that make C? Negative 1. And I already lost where A is on all of this. Where's A? There it is. So now we know that A equals 1. We have all 3. So we go back up. And we finish. This is 1 over X plus 1x minus 1 over x squared plus 4. The negative 1 for C. Let's go back. Right here, B plus C is equal to 0. So whatever B is, C had to be the opposite of that, so that they could add to be 0. No, just because of this equation here. If once you've what we really would have done once we found b is to go back up to one of these equations, like this one here. If b is equal to 1, if you subtracted 1, you could solve for c that one. Okay, you guys, the only way that's going to get easier is if you truly do the homework the way it's supposed to be done, not just writing the problem down and then going to the back of the book and seeing what the answer is and writing the answer down, which some of you are doing. Okay? Go from start to finish as if you didn't know what the answer was going to be. Get the answer and then look in the back of the book and see if it's wrong or right. If it's wrong, go back and fix it. Okay? That's really the way that you can learn. Since this is new material and it's very arithmetic intensive, I guess, you've got to make sure that you're doing the steps in the right order, that the steps are correct. That's not going to happen if you do 3 or 4 problems for practice. It's going to happen if you do 7 or 8 or 9 or 10. All of the problems that have been assigned for practice. Okay? And you don't have a lot of time to practice this, unfortunately. This is not something that can take its time to sink in. It needs to happen quickly. But you have a whole weekend to work on it, which I know most of you will. Some of you haven't done any homework all year long and probably won't start and aren't going to get to practice for this and is going to fail another test. But eventually it'll click that, hey, I've got to start doing homework if I want to pass this class. I don't know, can't force you. You've got to be the one that decides that. We are done with 10-7.